Okay, this video is to review some quadratic transformations. We've talked about transformations several times throughout this semester, and each time these transformations don't change. They all mean the same thing, they all have the same transformation. The equations just look a little bit different to find those transformations. So we've talked about having a parent function before. X squared is your parent function. Okay? That's your parent. That's the thing that we start from. Okay, that is your parent function. That's the original shape of your graph. Okay? The other three letters here are transforming or changing this parent function into something else. Remember, your A value can mean several things. One thing it can mean is a reflection. And remember, it's a reflection if it's negative. The second thing we can have is a stretch. That's if this A value is greater than 1. And the third thing is it's a shrink if that A value is less than 1. But that A value also has to be greater than 0. So here we're talking about fractions. Okay? Because that negative can only mean a reflection. Remember that your H value moves you left and it moves you right. Okay? But that left and rightward motion is always the opposite. Okay? It's the opposite because our vertex form equation, okay? Remember this is called vertex form. That's the best way to view all of your transformations in vertex form. It's already subtraction, so we always do the opposite. So if we're going to the left, it's because we saw a plus sign. And if we're going to the right, it's because we saw a minus sign. The last letter here, K, we can go up when it's positive, down when it's negative. Okay. Up when it's positive, and it looks like I wrote a positive twice on accident, down when it's negative. Okay. This K value, remember, also represents your max and your minimum. And the H value, this is your axis of symmetry. Because this is the X value of your vertex. And that K value is the Y value of your vertex. Okay. All right, so looking at these practice problems here, looking at these examples, we're moved from left to right, okay, because we know the parent function doesn't count. That's just our jumping off point. So we're looking for the other things that surround that. So 2 is in that A spot, and it's greater than 1, so this is a stretch. This is minus 4, so we're headed to the right. You always do the opposite. And this is a positive 3, so we're going up. On the second example here, the first thing we see is a negative. That negative tells me we have a reflection. And remember, technically that reflection's over the x-axis. Then we see the 2, which is bigger than 1, so that's still a stretch. So those are 2 different transformations, remember that, 2 different transformations. Now we see a plus 4, so we're going to the left, and a minus 3 is down. Then we have our next example here. We have 1/2. This 1/2 is less than 1. That's a shrink. We have minus 2, so that's going to be to the right. And then we have plus 1 to finish this off. That's going up. Looking at these though, before we move on to our last example, let's identify our vertex, our axis of symmetry, and our maximum and our minimum. That's a really good skill to have. So our vertex here is 4, 3. Our axis of symmetry is x equals 4. It's always the x value of our vertex. And just looking at this problem, how do I know if there's a max or a min? Well, is it positive or is it negative? This problem is positive. So if it's positive, it's going to be opened up. So then I have a minimum. And that minimum is at that y value of our vertex. Okay. Remember, you can also write your minimum as that ordered pair of your vertex, but this is a minimum. Let's look at the next one. My vertex is -4, -3. Remember, we're always doing the opposite, so we change the opposite sign for h. My axis of symmetry is x equals a -4. Now let's look at this problem. This problem's negative. So if it's negative, because we have a reflection, remember our parabola is flipped upside down. So that makes us have a max. Okay, and that maximum is at that y value of -3. Okay. Last example here, we have a vertex at 2, 1. That puts us our axis of symmetry at x equals 2. This is another positive function. So if it's positive, remember we're going to have a minimum. And that minimum is at the y value of our vertex. Another thing I can ask you about transformations is to write the equation given the transformation characteristics. So we're going to start in our vertex template. Okay, so that's always true. Then we'll go through and we'll read. We have a reflection, that's negative. We have a shrink of 1/3, so that goes out front. Then we're going to the left 3. So left 3 means we need to make this a positive 3. And then up 2 plus 2. And then we've written a function for our equation. Remember, functions and equations should have a y equals, and this should be g of x, shouldn't it? Because that's what we changed it to when we transformed it. Okay. This recaps transformations rather quickly. If you need more examples, please look at the blog at the first unit we did online. Happy studying!